بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 6.2, a volume by disks and washers. A solid is obtained by revolving the shaded region about the specified line. Set up an integral for the volume of the solid about the x-axis. Let me remind you, when we rotate about the x-axis using this method, disk and washers, the formula is integral of pi radius square to the power 2 dx. And we choose a rectangle which is perpendicular to the axis of rotation, and the axis of rotation here is the x-axis. And pi is always there in the formula, and the radius is the distance from the axis of rotation to the curve. So it is this distance. And you can see that this distance is y equals f of x. So the radius here is always y equals f of x, which is x squared plus 5. So in fact, the integral would be integral from, of course, a to b. Look to x here, from where? From 0 to 3 pi, and the radius is x squared plus 5 to the power 2 dx. And that's the integral. Again, about the x-axis, notice the difference between this exercise and this and the previous one. Here, when you rotate this region, you have a solid, okay, because there is no space, there is empty space between the region and the x-axis, the axis of rotation. But here, when we rotate this region, okay, we will have a washer, not a solid, because there is an empty space between the region and the axis of rotation. So here the formula is the same, but we have uh, an outer radius and an inner radius. So the volume would be integral from a to b pi times. We have outer radius square minus inner radius square dx. So instead of radius square, we have outer radius and inner radius, because now uh, we have, for this rectangle, this would be the rectangle, okay? To find the length of this rectangle, we have to subtract these two quantities, okay? So the distance from the axis of rotation to the outer curve, this distance is called the outer radius. Now, how to find the outer radius? If this is x, then the length of this line segment is f of x, which is square root of x. So the outer radius here, outer radius is square root of x. That's the outer radius. Now for the inner radius, I need the distance from here to here, to this line, to the inner curve. This line is half x, so the radius would be y equals to half x. So the inner radius is half x. So now I can find the volume. X runs from 0 to 4 pi times square root of x to the power 2 minus half x to the power 2 dx. You can write it if you like from 0 to 4 pi times square root of x squared is x squared minus 1 over 4 x squared. So this would be the volume. It is the integral of this. Now, when we rotate about the x-axis, the equation or the volume would be given by pi equals radius square. But here, the the rectangle is, as usual in this method, perpendicular to the axis of rotation. So the width of the rectangle is delta y. So we are integrating with respect to y. And the radius here is the distance from the axis of rotation to the curve, this distance. Okay. And this distance should be written as x equals f of y. So in terms of y. And y runs from C to D. Notice that here we have a solid. This region is no empty space between this region and the y-axis, the axis of rotation. So when you rotate, you get a solid. Well, what is the radius here? The radius should be x equals f of y. Well, the function is solved for y, so we need to solve it for x. So x cube equals y minus 1. If you take 1 to the other side, then x is cube root of y minus 1. So this would be the radius. So the volume would be equal to, now 0 c d y runs from where? From 1 to 9, from 1 to 9, pi times the radius is the distance from the uh, axis of rotation to the curve, which is x equals f of y, or cube root of y minus 1. You raise it to the power 2 and you write dy. So this is the integral. Again about y-axis, but if you notice here, there is an empty space between the region and the y-axis. So when you rotate this region about the y-axis, you will get a washer. Okay, we will use a horizontal rectangle because it should be vertical to the axis of rotation. In this method, always the rectangle. And since we have a washer, then the volume would be given by the integral from C to D pi times outer radius square minus inner radius square dy, where all the radius, the outer radius, is written in terms of x, and also the inner radius is written in terms of x. I mean, in terms of y, sorry. X equals f of y or g of y in terms of y. So let us determine the outer radius and the inner radius. Well, the outer radius should be, you start from the axis of rotation, you go to the outer curve. This is the outer curve. So this distance, now you think of this distance and try to find the outer radius. You need to think a little, okay, and consider everything. Well, this distance is equal to x, okay? This distance from here to here is because if you have any point here, this point, what are the coordinates of this point? It would be x and y. The coordinates of this point are x and y. So what is x? X is the distance from the y-axis to this point. So that's x. And y is the distance from here to here, from the point to the y to the x-axis. Good. So so this distance is x. How to find it? X of what? X of this line. Well, this line has the equation y equals x over 2. So we have to solve it for x. We multiply by 2. So x would be equal to 2y. So the length of the outer radius is 2y. The inner radius, the distance of the inner radius is from here to here, to this curve, to the inner curve. Again, the coordinates of this point is xy, so this distance is x, but it is x of this curve, okay? And this curve is y equals 2 over x, so we can write it x equals 2 over y. Interchange x and y, okay, or multiply cross product. So x would be 2 over y. So this is the inner radius, 2 over y. And now you can write the volume. Well, from where to where? From here y is equal to 1. From 1 to here, y is equal to 2. So from 1 to 2, the region is bounded from 1 to 2 on the y-axis. Uh, pi times. What is the outer radius? 2y square. So I will write it immediately, 4y square minus the inner radius. So it is 4 over y square dy. And that's it. Set up but do not evaluate an integral for the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. All right, we need to sketch the graph to understand everything. So y equals to 0. This is the line y equals to 0, the x-axis. Okay. X equals to 3, 1, 2, 3. So this is the line x equals to 3. Okay. Y equals ln x. We know the graph of y equals ln x. This is a vertical asymptote. And len 1 is 0. And the graph of len goes like this. Okay. So where is the region bounded by x equals to 3? This is the line x equals to 3. And y equals to 0, the x-axis, and the curve len x, it is this region. So now what do we want to do? We need to rotate this region, revolve this region about the x-axis. About the x-axis. So we will take a vertical rectangle to the x-axis, perpendicular to the x-axis. Good. And it's a solid. We have a solid. So the volume would be x from where to where? From 1 to 3. Pi times radius square. What is the radius? It is the length of this line, okay? And it has to be written in terms of x, so it's y equals, and that's the curve actually. This is the curve y equals ln x, so it is ln x square. So that's the volume. Let us sketch the graph. We have y equals 0, the x-axis, x equals 0, the y-axis, and x equals the square root of 5 minus y. If I put x 0, let me graph it like this. Let me choose some points, okay? Put x 0. So square root of 5 minus y equals 0. 5 minus y would be equals to 0, or y is 5. So 1, 2, 3, 4, 5. This is one of the points. And it's the y-intercept actually. If you put y 0, then x would be square root of 5. So, and square root of 5 is 2 point something. So it is 2 point, let us say 2, according to the calculator, 2.2. So this is 1, this is 2, and this is the x-axis. Now what is the graph of this curve? If you square both sides, okay, you know that, and if you solve for y, so it's negative x squared plus 5. So actually you know that this is a parabola. This is a parabola opens downwards because of this negative, and we have moved it 5 units up. So actually it is this parabola, okay? It's going down. But now x is positive, so it's not a parabola anymore. X equals square root of 5 minus y. This is half of the parabola, and it is this half to the right of the y-axis, because x is positive, okay? You can continue graphing all the parabola, but this region is the region we need because it is bounded by this curve. Now this is the curve x equals, this is now the curve x equals square root of 5 minus y, and the line, the y-axis and the x-axis, okay? Where we want to rotate this about the y-axis. When we rotate about the y-axis, we will get a solid, and this is the rectangle. The width is delta y. The rectangle should be perpendicular to the axis of rotation as usual. So the volume would be y now dy. So y from where to where? From 0 to 5. It's a solid, it's not a washer. So one radius, pi times radius squared. This is the radius, the distance from here to here, and it is x. This distance is always x because this point is x and y. Okay, so this distance is x, which is square root of 5 minus y. So square root of 5 minus y, when you raise it to the power 2, you get 5 minus y, and this would be the volume. 8y equals x squared, y equals the square root of x. We know the graph of y equals the square root of x. And what about this one? Well, this is y equals 1 over 8 x squared. So it's a parabola. It's a parabola opens upwards, but 1 over 8 is a kind of shrinking. Okay, so if x is 0, y is 0. If x, let us say we need to find the intersection points between the two graphs. So I will put 1 over 8 x squared equals square root of x. This is y of this curve, and this is y. So we solve the two equations together. If we multiply by 8, I'll have 8 square roots of x. Now, if I square both sides, I will have x to the power 4 equals 64x. So take everything to the left-hand side. Take x as a common factor. So x times x minus 4 to the power 4, yes, 4 to the power 3 is 64. So I can factor, or let me do it like this. Now I have either x is 0 or x cube is 64, which means x is cube root of 64, and cube root of 64 is just 4. So the intersection points is at 0, 0, 0, and 4. 1, 2, 3, 4. Square root of 4 is 2, so this point has coordinates 4 and 2, and this is the region. Of course, the other curve is this curve. Oh, the region is not correct because I did not sketch the graph of the second curve. Let me sketch the graph of the second curve first. That's the second curve, which is the parabola. Okay. So this is the region, not this one. No need of this line. This is the region bounded by, enclosed by these two curves. About which axis? About the y-axis. Okay, about the y-axis. Good. We will take a rectangle perpendicular to the y-axis. And we have a washer because of this empty distance. So we have an outer radius and an inner radius. What is the outer radius? Delta y is the width. The outer radius is the distance from the axis of rotation to the outer curve, to this curve, which is the parabola. The parabola is y equals 1 over 8x squared. Well, this distance is x. Okay, so we need to solve the parabola for x. If you solve it for x, x would be plus or minus square root of 8y. But we are in the positive side, so x is positive. So x is square root of 8y. So that's the outer radius, square root of 8y. The inner radius is the distance from the axis of rotation to the inner curve, to this curve. This distance is also x, but x in this case of the curve, the square root. So we need to solve this for x, square both sides. So x is y square. So the inner radius is y square. And now we can write the volume, the integral for the volume. Well, from where to where? This point is 4, 2, so y is from 0 to 2 pi. Outer radius, square root of 8y raised to the power 2. Inner radius, y square raised to the power 2 dy. This will give the volume of the solid obtained by the washer in this case, obtained by rotating this region about the y-axis. About the x-axis, I have a line and a parabola. This is the parabola, y equals x minus 2 squared, so it is the same parabola, x squared, but moved 2 units to the right. So 1, 2, this is the parabola. Y equals x plus 10, this is a straight line. If x is 0, y is 10. Okay, this is 10. And if y is 0, x is negative 10. So this is the line, y equals x plus 10. And the parabola will go up from here and up from here. All right. So there will be an intersection between the line and the parabola. I think I need to sketch the graph again because they will intersect up. So I need to increase my x and y units. So I'll do it here. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. And this is 10 anyway. So that's the line. And now the parabola is going like this, and they will intersect somewhere. So let us find the intersection points. So x plus 10 equals x minus 2 squared. You equate the two equations. So x plus 10 equals x squared minus 4x plus 4. Take everything to the right hand side to here. So x squared minus 4x minus x, so you will have minus 5x, okay? And plus 4 minus 10, that's minus 6 equals to 0. So I wrote the right hand side as the left hand side. And now if you factor, so x is 6 and x is negative 1. So 6, if you put x 6, y is 16. And if you put x negative 1, y is 9. So these are the intersection points, negative 1 and 9, this one, and 6 and 16. So this point is 6 and 16. And this point is 0 and 9. These are the points of intersection. Now, we need to rotate this region about the x-axis. Good. It is not a solid because there are empty spaces. So it's a washer. When we rotate, the solid of revolution would be a washer. All right, let us find the outer radius and the inner radius. To find the outer radius, I'll go from the axis of rotation to the outer curve, okay, which is this one. Of course, this is the region. We need to find its the volume. So this, the distance, the length of this line would be the outer radius. Well, it is, if you choose this point, what are the coordinates of this point? X and Y, so it's Y. Okay, it's Y of this point, X. So this line, remember we are finding uh, rotation with about the x-axis. So the rectangle would have a width of dx, and everything should be in according with respect to x. So this line x plus 10. So that's good. It is already there. So x plus 10 is the outer radius, and the inner radius would be the distance from here to this point. Well, again, this point xy, but x of the parabola and y of the parabola. So the length of the vertical distance, this distance is just y of the parabola. So that's the inner radius. So the inner radius is x minus 2 squared. And now we can find the volume. X from where to where? This is not 0 and 9. This is negative 1 and 9. So it's from negative 1 to 6. X is negative 1 here, and x is 6 here. So it's from negative 1 to 6. Pi times outer radius x plus 10 to the power 2 raised to the power 2, so it would be to the power 4, minus x minus 2. Well, y equals x plus 10. Okay, so the outer radius is just x plus 10. There is no square here, because it is just the line, the equation of the line, y equals x plus 10. But here it's y equals x minus 2 squared. So when we square it, we will have 2 here and 4 here, because this is the inner radius, dx. So again, this was the region, and the volume is pi times the outer radius. This is the outer radius, y of the line, which is x plus 10, and minus the inner radius, which is uh, the equation of the parabola, x minus 2 to the power 2. So this will give you the volume of the solid of revolution. Another question, y is 0, that's the horizontal axis. X is 4, that's this line, the vertical line. Y equals square root of x, this is square root. If x is 4, y is 2, and 0, 0. So this is the equation of y equals square root of x. And this is the region we need to find. Uh, we need to rotate, but here we will rotate about a line, about x equals to 6. So let us call this additional exercise. So x equals to 6, that's the line x equals to 6, 4, 5, 6. This is the axis of rotation. It's parallel to the y-axis, so it is as if we are rotating. I mean, we use the formula. We take a rectangle parallel to, perpendicular to the axis of rotation with width delta y, so everything would be here in terms of y. So from 0 to 2, pi times. Now we need to find, we will rotate, imagine we will rotate this region about the line, about this line, okay, about the black line, x equals 6. So what would be the outer radius in this case? Well, the outer radius is always, and please pay attention, the distance from the axis of rotation to the outer curve. So this distance is the outer radius. the outer radius. Notice that this distance from here to here is x, because this point is a point on the curve with coordinates x and y. So it is x, okay, of the curve. So this is y equals the square root of x. If you solve it for x, it would be x equals y squared. So this distance is y squared. But I need the red distance. Well, this equation, this line has equation x equals to 6. And the distance from here to here is fixed. It is always 6. Okay. From here to here, it is always 6. So this distance is 6. And the small black distance is x equals y squared. So you can figure out now that the length of the red line segment is just 6 minus x or y squared. So this is the outer radius. Just do it like this, okay? It would be easy with you. Let us try the inner radius. And let us use another color. So the inner radius, where the distance from where you start from the axis of rotation. And you go to, now, where is, that's the region. So there is no, yeah, where is the inner? This is the curve in this case. This is the inner distance because we are rotating this region about the line. So there is an empty, this is empty, okay? So make sure that you understand that that's the region we are rotating about the line x equals to 6. So this is the inner radius. We will get a washer. This is the inner radius. Well, it is easy because this is 6 and this is 4 and this is a vertical line. So the inner radius is always 2. It is fixed. It's not a curve that's changing like the square root of x here. So the inner radius is just 2. So the inner radius is 2 and the outer radius is 6 minus y squared. So now we can write the equation of the volume. It is pi times outer radius square minus inner radius square dy, and y runs from 0 to 2. Find the volume of the solid obtained by rotating the region bounded by the given curves about the specified line. Okay, y equals x plus 1. This is a straight line. If x is 0, y is 1. If y is 0, x is negative 1. So that's the curve. And the line y equals to 0, that's the x-axis. X equals to 0. That's the y-axis, and x equals to 2. So where is this region? Again, y equals x plus 1, that's the line. X equals to 0, that's the line. X equals to 2, that's the line. Y equals to 0, that's the line. So this region is actually bounded by all these 4 lines. Well, we will rotate this region about the x-axis. Once we rotate about the x-axis, we will take a rectangle perpendicular to the x-axis with width delta x. And you can see that this is a solid. So here the volume is should be easy. Volume equals delta x from where to where? From 0 to 2. Pi times the radius. What is the radius? It's from the distance from the axis of rotation up to the curve. What is the curve? It should be written in terms of x. So x plus 1. So x plus 1 is the radius, this distance, because this line is y equals x plus 1 to the power 2, because pi times radius square dx, and this will give you the volume of this region. Y equals 1 over x. You know the graph, it's like this. Y equals 0 is the x-axis. X equals 1 is this line. 2, 3, 4, x equals 4 is this line. Now the curve, if x is 1, 1 over 1 is 1. And if x is 4, 1 over 4 is 1 over 4. So this is the curve 1 over x, y equals 1 over x. And this is the region we need to find the solid of revolution obtained when we rotate this region about what? The x-axis. So about the x-axis, we will take this rectangle, delta x is the width, and immediately the volume would be x from where to where? From 1 to 4. It's a solid, so it's pi times the radius. The radius is this distance to the line. It should be written in terms of x, which is 1 over x already. So this is the volume. Y equals square root of x minus 1. This is y equals to square root of x, but taken 1 unit to the right. So that's the graph. This is y equals to 0 and 2, 3, 4, 5. This is the line x equals to 5. When x 5, 5 minus 1 is 4, square root of 4 is 2. So this point has coordinates 5 and 2. Y equals to 0, x equals to 5, and the square root function. So this is exactly the region. We need to rotate this region about the x-axis. So we will take a vertical rectangle like this, and the volume would be given by this equation. Delta x from where? From 1 to 5 pi. What is the radius? Okay, the distance from here to here. Okay, it's y of this curve, which is square root of x minus 1 to the power 2, or just square root, just x minus 1. So this would be pi radius square dx. This will give you the volume of the solid of revolution. Y equals e to the power x. Y equals 0, the x-axis. X equals negative 1 is this line. X equals 1, it is this line. E to the power negative 1 is 1 over e. So if this is 1, 1 over e is about here. And if x is 1, so if x is 1, this is 1, this is negative 1. If x is 1, e to the power 1 is e, which is 2.7, so it's about here. And of course, we know that e of 0 is 1. So this is the graph of the curve y equals e to the power x between negative 1 and 1. And the region bounded by all of these lines and curves is this one. So x minus 1 and x equals 1 and y equals 0. Notice, okay, all of them, all of the curves. Y equals 0, uh, x equals 1, x equals negative 1, and the curve e to the power x. So this is the region, and we need to rotate this region again about the x-axis. So we will just take a rectangle vertical to the axis of revolution, and it's a solid. We can immediately write the volume. Well, the volume would be integral from -1 to 1. Okay, the width is delta x. Pi times the radius. The radius is this distance from the axis of rotation to the curve, which is e to the power x raised to the power 2 dx. This would be the volume. Notice that ex to the power 2 is just e to the power 2x. So this would give you the volume of the solid of revolution. X equals 2 square root of x equals 0. Well, x equals 0 is this line, the y-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is y equals 2, 9. This is y equals 2, 9, the horizontal line, and the line x equals to 0, and this curve. Well, this curve, if y is 0, x is 0, so it passes by the point 0, 0. And I'd like to know if y is 9, what would happen? If y is 9, 2 times square root of 9, 2 times 3, that's 6. So x is 6, 1, 2, 3, 4, 5, 6. So it will intersect this line at this point, and it would go like this. Remember, if you square both sides, you will have x squared equals 4y. And if you solve it for y, it is 1 over 4x squared. So it's just a parabola, opens upwards. But we are taking the positive, the positive half. X is positive, okay? So we are taking the right half of this parabola. So where is the region bounded by all of these curves? X equals to 0. This is the line. X equals 2 square root of y. This is the curve. Y equals 9. This is the line. So this is the region. We will rotate this region about what? About the y-axis. About the y-axis, so we will take a curve like a rectangle, horizontal rectangle, and the width is delta y, and it's a solid. So the volume would be equal to y from where to where? From 0 to 9 pi. What is the radius? It is this distance, and this distance is just x because this point has coordinates x and y. Which x? It is x of the parabola, which is 2 square root of y. You raise it to the power 2 dy. This will give you the volume. Uh, Another graph, y equals to 4, x equals to 0, 2x equals y squared. If you solve this equation for x, or let us just replace x by 0, y, so it passes by 0, 0. And what happens if y is 4? If y is 4, this would be 16, 2x equals 16, so x equals 8. So this is 8, so 8 and 4, this would be the point of intersection between the line and the curve. This is the line. Why I draw the line like this? Actually, if you remember, this is x equals half y squared. So it's a horizontal parabola. It opens to the right because half is positive. Okay. Where is the vertex? Well, the vertex, we find k negative b over 2a. B is 0 here, so K is 0 and H is 0. So actually, this is the vertex. So this graph is not accurate because the parabola opens, this is the vertex of the parabola, and it goes like this. Okay. So where is the region now bounded by all of these things? Y equals to 4, curve 2x equals y squared, and x equals to 0. So it is this region. We will rotate this region about the y-axis. So we take a rectangle, horizontal rectangle with delta y. Again, it's a solid, and the volume would be given by from where to where? From 0 to 4 pi. times radius square. What is the radius? It is the distance from here to here. This point has coordinates xy, so it is the x coordinate of this point. Well, the x coordinate of, or the x, if we solve the equation of the parabola for x would be half y square. So it's half y square, that's the radius raised to the power 2 dy. Y equals x square, I know this parabola, and y equals 2x, it would be a line like this. This is the line y equals 2x. Okay, I need to know where they intersect. So x square equals 2x, or x square minus 2x is 0. So x times x minus 2. So either 0 or 2. So this is 2. 2 and what? If you put x2, y would be 4. So this is the point 2, 4. All right, about the y-axis. Now we will get a washer. About the y-axis, we will get a washer. We will take a rectangle perpendicular to the, the axis of rotation. And now we need to find outer radius and inner radius. And the outer radius is the distance from the axis of rotation to the outer curve. We reach a point on the curve, so it's xy. So it's x of the curve. The curve is y equals x square. So if we solve it for x, it would be x equals square root of y. We are in the positive side. So the outer radius is square root of y. The inner radius is the distance from the axis of rotation to the inner curve, which is again x, because this point has xy. But this time x is on the line. X on the line is half y. So the inner radius is half y. And the volume would be given by dy, so y runs from 0 to 4. Outer radius is square root of y. When you raise it to the power 2, it's y. Half y, when we raise it to the power 2, it's 1 over 4 y square dy. Y equals 6 minus x square. This is a graph of a parabola, opens down, taking 6 units up. So it goes like this. This is the line y equals 2. So they will intersect somewhere, and the region, this region, and we will rotate about the x-axis. So I'd like to know the intersection points between the parabola and the line. So 6 minus x square equals to 2, or x square equals to 4, or x is plus or minus 2. So this point is negative 2 and something, and this point is 2 and something. Actually, the y coordinate is not important for me here, but it is easy because the line is y equals 2, so the y coordinate is always 2. Now, alhamdulillah, if we rotate this region about the x-axis, we will take uh, a rectangle like this, okay, vertical rectangle, and it would be a washer, not a solid, because there is an empty space between the region and the axis of rotation. So we need to find the outer radius and the inner radius. Well, the outer radius is the distance from the axis of rotation to this curve, the outer curve. And this distance is, notice that this point is xy, okay? So this distance from here to here is y of the curve, okay? So this point is xy. So if you give me -1, for example, this would be the y of the -1. So this distance is y. So that's the outer radius. While the inner radius is the distance from here to here. And the distance from here to here is fixed because this is the line y equals to 2. So the distance is 2. So the outer radius is y and the inner radius is 2. So the volume would be integral from, it is delta x, so from -2 to 2 pi times. The outer radius is the y, but which y? Y of the curve, which is 6 minus x squared. So it's 6 minus x squared to the power 2 minus 2 to the power 2 or 4, and this will give you the volume. Y equals x cube and y equals square root of x. X cube is like this and square root of x is like this. So this is the region. If you want to find the intersection points, you just equate x cube and square root of x, you raise to the power 2. X to the power 6 would be x. You take it to the other side and take x as a common factor. So either x is 0 or x to the power 5 is 1, which means x is 1. So the points of intersection are 0. If you replace x by 0, you get 0. If you replace x by 1, you get 1. So this is the point 1, 1. We need to rotate about the x axis. So we will take a vertical rectangle. And now we have a washer. And we have outer radius and inner radius. Outer radius is the distance from the axis of rotation to this curve. This is the curve y equals square root of x. This point has coordinates x and y. So it is the y of this curve, which is square root of x. And the inner is the distance from here to here. And it is the y of the curve x cube. So this distance is just x cube. And the volume would be now from 0 to 1. Okay, it's delta x from 0 to 1. X is 1. Pi times the inner radius is square root of x. This is the outer, sorry. Raise it to the power 2. And x to the power 3, raise it to the power 2. So this will give you the volume. X equals 2 minus y squared. Well, this is a parabola with k equals 0 and h equals 2. So the vertex is 2, 0. And it opens to the left. So 1, 2, and it opens to the left. And the line x equals y to the power 4 is similar to x equals y square. So it passes by 0, 0, and it opens like this. It goes like this. So we need to find the intersection points between these two curves. So let me equate 2 minus y square equals y to the power 4, or y to the power 4 plus y square minus 2 is 0, or y plus 2, y square plus 2 times y square minus 1 is 0. Okay, so this has no real zeros, but here we have y square equals 1, so y is plus or minus 1. So the intersection points would be y is 1 or negative 1. If y is 1, x is 1. If y is negative 1, also x is 1. So 1 and 1. So here at negative 1 and at 1. So this is where they intersect. Okay. So this point is 1, 1. This point is 1 and negative 1. This is the region. we need to rotate this region about the x-axis, the y-axis. Well, about the y-axis, we will have, there is an empty space, so it's a washer. So this is from here to here is the outer radius, and from here to here is the inner radius. Well, the outer radius, in this case, we reach a point here, which is xy. So it's x of this curve. What is this curve? It's 2 minus y squared. So that's the outer radius. The inner radius is this distance. And we reach a point on the curve, which is xy. So it's x of this curve, which is y to the power 4. So the volume would be, remember, we are taking the rectangle here is uh, perpendicular to the y axis, the axis of rotation. So delta y, so y runs from -1 to 1, all right? And pi times the outer radius 2 minus y squared to the power 2 minus y to the power 4 to the power 2, or just y to the power 8. Now these are additional exercises about y equals 1. Well, y equals x squared, we know the graph, and x equals y squared. So this is y equals x squared, and x equals y squared is like this, a horizontal parabola. So it is this region. It is this region. And it's about the line y equals 1. We would like to know the intersection point. It's 1, 1, but let us make sure that it is 1, 1. Okay, or learn also how to find the intersection points. Well, I have y equals x squared and x equals y squared. So I'll take the first one, y equals x squared. I will find it from here. So from the second equation, x squared is y to the power 4. So I'll have y equals y to the power 4, or y to the power 4 minus y is 1. If you take y as a common factor, so either y is 0 or y is 1. If y is 0, x would be 0. And if y is 1, x would be positive and -1 here. But here it would be 1 because x is in the positive direction. So actually this point is 1, 1. All right. About the line equals 1. So we are rotating this region about this line. This is the line y equals 1. Now pay attention how to find the outer radius and the inner radius. Well, the outer radius is the distance from the axis of rotation to the outer curve. So it's this distance. Now you reach a point here on this curve xy, but this is not y. Okay, this is not y of the curve. Y of the curve is this one. This distance is y of this curve, which is x squared. Okay, so remember this whole distance is 1 from 1 to 0 because this is y equals to 0. So the black line segment has the distance or has the length of 1 minus this y, which is x squared. Notice that here we will have a rectangle vertical, so delta x. So we have to write everything in terms of x, which is the case. Inner radius is this distance to the inner curve. This is the y. Again, this is the y of this curve. So we have to write it in y. So it's a square root of x, positive or negative, but we are in the positive side of y. So square root of x. So the inner radius would be 1, the blue one, minus the blue one here, which is square root of x. This will give you the black distance or the inner radius. So the volume would be dx, so x runs from 0 to 1, pi times the outer radius, which is 1 minus x squared to the power 2, minus the inner radius, which is this one, dx. Still another two examples. I'm sorry it's too long, but I wanted to solve a lot of uh, questions about this idea. Hopefully you will understand everything about it. So y equals 1, this line, x equals 2, this line, and y equals x cube, it is this one. Okay. If y is 1, if y is 1, x cube would be 1, so x would be 1. So this is the curve. This is the curve, y equals x cube. So now y equals 1. Let us find the region. Y equals 1. That's the region. X equals 2. And the curve y equals x cube. Well, the region is not clear here because he must says y equals 0. Okay. So y equals x cube. This is the graph of y equals x cube 0, 0, 1, 1. If x is 2, it would be 8 up. So let us go up. Let us go up. This region is not a good region. It is not the one he is asking about. Maybe I need to go up. So at 1, at x1, yx cube y is 1, and at x2, y is 8. So this is the curve, y equals x cube. And the line, y equals 1. This is the line, y equals 1. And x equals 2 is this line. So now I can see the region. It is this region. Because it's bounded by y equals 1, x equals 2, and the curve x equals y equals x cube. Okay, so you need to spend some time making sure that uh, our curve, our region is accurate. Good. We rotate about what? About the line y equals -3. Okay, 1, 2, 3. Good. So our rectangle would be like this. And so it would be delta x. We need to find the outer radius and the inner radius. Well, the outer radius would be the distance from where? From the axis of rotation to the outer curve, which is this curve. Well, this is the x-axis. This point has coordinates x, y. So the y is this distance. This is the y of this point, and this is the x of this point. Okay? You go to the x-axis. Here you go to the y-axis. So this distance is y, but this distance from -3 to 0, this is fixed. This is 3 because the distance from 0 to 3 is always 3 distance, okay? So this is a 3 plus this, which is the y of the curve. The y of the curve is x cube. So the outer distance is 3 plus x cube. Inner radius For the inner radius, I will go from the axis of rotation to here, to this line, because it is the inner. Okay, it's below this one. This is the line y equals 1. So the distance is 4. So the inner radius is 4. So the volume would be integral with respect to x. So from 1 to 2 pi outer radius minus inner radius square. This will give you the volume. Finally, the last question. Y equals x cube, y equals 0, this is y equals 0, x equals 1, this is x equals 1. Okay, this is the line, x equals 1. So y equals x cube. If x is 0, y is 0. If y is 1, y is 1. So that's the curve. So do we have the region? Y equals 0, x equals 1, and the curve. So this is the region. We need to rotate about the line x equals 2, about this line. So we will choose a rectangle like this, and we will work with respect to y. Let us determine the outer and the inner radius. The outer radius is the distance from the axis of rotation to the outer curve, which is this one. What is this distance? Pay attention, please. This point has coordinates x, y. But what is x and what is y? Y is, this is x and this is y. You know this fact. I think it's a fact. Everybody knows it. If I say that this is the point x, y, so this is x and this is y. It's always like this. Okay. So this small uh, distance, small line segment x, and this is y. So this is x and this is 2. So the distance from here to here is always 2. So to find the length of the black line segment, it's what? It's 2 minus this x, the red one. Well, this x is x of the curve. This is the curve. Y equals x cube. So I solve it for x. So it would be cube root of y. So this would give you the length of the black line segment. The inner is from here to here, to this line. And this is 1 and this is 2. So the inner is also always 1, has length 1. Because this is the region. This is the region. This is the region. So in this case, this is the outer curve and this is the inner curve with respect to the line x equals to 2. So what is the volume? Y runs from where to where? We need to find this point. It is 1, yeah? When x is 1, y is 1. So from 0 to 1 pi. The outer radius is 2 minus cube root of y. Remember, we are rotating about the line x equals to 2 minus 1 dy. I hope this was interesting for you, and I hope you understand now everything related to disk and volume by disk and washer. Thank you very much.